So we found that there were horizontal tangents at 2 pi thirds and theta equals 4 pi thirds. And we don't know what's going on here at 0, and we can see that that comes in on both sides here for our cardioid, so that's a questionable one that we're going to deal with in a minute. So now we're interested in vertical tangents. Vertical tangents would be when the denominator was 0 but the numerator was not, when the change in x with respect to theta was 0 but the change in y was not also 0. So let's go ahead and look at that change in x with respect to theta, and we're going to put it equal to 0, and I'm going to go ahead and factor out a sine theta while I'm doing this. And I think I'll write this one first. 2 cosine theta minus 1, and that equals 0. So we see that that equals 0 when sine theta equals 0 or when cosine theta equals 1/2. So as we're looking to determine that, well, this one would be when theta was 0 or pi. And we know that the 0 was an indeterminate, so we're not going to use that one at the moment, and we'll deal with that in a minute. And then when is the cosine 1/2? And we know that's the x value, so that's right here and here. And so that's going to be at pi thirds and at 5 pi thirds. Now, checking these values, we threw out the 0, but the numerator is not 0 at any of these other three, and so they are places where we have vertical tangents. And we can see that that's the case here. Here is when theta equals pi, and then this one is when theta equals pi thirds, and then here's the one when theta equals 5 pi thirds. Now, to look at our indeterminate case, we had 0 over 0. So what we really want to know is what happens as we're approaching 0 here, because we don't know if we're going horizontal or vertical. So we are going to take the limit, and so I'm just going to squeeze that in the interest of room on the screen. So we're going to take the limit as x approaches 0. Will approach from the right hand side of this derivative, and so we want the limit as x approaches 0 from the right hand side, and we have this 0 over 0, so we can apply L'Hopital's rule to this. And so let's go ahead and do that. And so here we have negative sine theta, and this would be minus 2 cosine theta sine theta, and that's going to make that a plus, and then this would give us a 2 sine theta cosine theta, so we can actually go ahead and combine those. So this will give us a 4. And then now I got to fix one more thing. I need to put this limit on here. So let's go ahead and do that. So we did this by L'Hopital's rule, and we're looking at the limit as x approaches 0 from the right hand side. Now we're doing the derivative of the denominator, so that's going to be negative cosine theta, and then here if we have first times the derivative of the second, we're going to have 2 cosine squared theta, and then second times the derivative of the first minus 2 sine squared theta. Then we have a look at this to see if we can now directly evaluate, and we can see that if we put in 0, the numerator is still 0, but as we put in 0 down here, the denominator is not 0 because this part is 0, but here we'd have 2 minus 1, which is 1. So the limit as x approaches 0 is 0 over 1, which is 0. So that does let us know at 0 that we have a horizontal tangent, because dy dx does equal 0. So we've got one more horizontal tangent right here at 0. So to summarize, our verticals were at pi over 3, and 5 pi over 3. Those were our verticals. And our horizontals were when theta equals 0, 2 pi thirds, and 4 pi thirds.